Okay, and as we were saying in the last video, this end behavior is critical as we start moving into calculus. We're getting ready for calculus. The way we read this is as x approaches infinity. So that means as you go to the right-hand side on your graph, and as x approaches negative infinity, that would be as you go to the left side on the graph. And the way we can sort of approximate what's happening is for a polynomial function of this form, we're going to be looking at the leading term here. Not that the rest of it is not important, but this is going to dictate the behavior. So I take this leading coefficient, and I'm looking at the sign of the coefficient as well as the degree of the polynomial. So as we look at these things, we've got four possible combinations. My degree could be even. So this could be something such as x squared, x to the fourth, etc. And if I've got my leading coefficient is positive, 1, 3, anything that's greater than 0. So that's similar to a quadratic. On a quadratic, as you move to the right-hand side of the graph, your function is moving upwards. As you move to the left-hand side, it is also moving upwards. Notice both directions are going the same, or both ends are going the same direction. And of course, there's stuff going on in between here and here. We're just looking at the far extremes on a graph. Likewise, if my degree is even, but the leading coefficient is negative. So imagine a quadratic that has been reflected across the x-axis. As you approach negative infinity in x, the y values are getting smaller. As you move to the right, the x's get bigger and the y's get smaller. Both ends are going the same direction. They're both going downwards. Y is getting smaller here. Okay, if we have degree that is odd, so this is a function such as x to the third, x to the fifth, etc. Again, two possible combinations here. If our leading coefficient is positive, so 1, 5, 3, anything that is positive, it could be even or odd in front. As we go to a positive x value, the y's are getting bigger. So this is as x approaches infinity, y approaches infinity. As we move to negative infinity, so as x approaches negative infinity, y is getting smaller. So on our odd functions, our end behavior goes in opposite directions. We go down here, up at this end. The opposite is true if our leading coefficient is negative. That's caused it to reflect across the x-axis. So this would go up as you approach negative infinity with x, and x approaches positive infinity. The y values get smaller and smaller. I know this seems confusing, but we're going to put all these pieces together now. Okay, let's take a look here and see what we've got. Okay, example 7. So I've got this polynomial, and the important things here is my leading term. Don't worry about these other pieces quite so much, because this is what's going to dictate the behavior. Well, first of all, we know the degree is 4, which is an even number. So degree is 4, and the leading coefficient is a 1. 1 is a positive number. So if we look at our little box here, degree is even, leading coefficient. My two ends both need to go upwards. So can we rule out any graphs for approximating this? Graph D, both ends go downward. So that's not acceptable. Okay, so now we've got to figure out which one of these three is the correct approximation. Well, let's keep in mind, if the degree is 4, what does that tell us about the number of turning points? Well, we should have a maximum of degree minus 1. So 4 minus 1 is 3. The most we would have is 3 turning points. This one has 1, 2, 3, 4, 5. That is not acceptable. Okay, we've got 2 left here. How will we just tell which is the correct one? And again, we're not using the calculator to tell this. What we're going to do is have to look at our y-intercepts, because look at how different the y-intercepts are. Okay, so y-intercepts means you plug 0 in for x. So a 0, 0, 0, 0. Each one of these is multiplied by 0, so they cancel, leaving a negative 6. So my y-intercept is negative 6. This one has a positive y-intercept. This one has a negative y-intercept. And again, I don't care about the actual value, but that one was unacceptable because we know our y-intercept is negative 6. Okay, how do we use all this information? So what we're going to do here is we're creating the steps for analyzing the graph. The first step is we need to determine the end behavior. So determine the end behavior. And again, we need our degree from the leading term and the coefficient. Is it positive or negative? We need to find our x and y intercepts. Become experts at that now. We need to determine the zeros are the solutions, and whether the graph will cross or touch. Sometimes that's called bounce at each x-intercept or each zero. So at each one. Okay, step 4, determine the maximum number of turning points. And again, our maximum number of turning points is 1 less than your degree. Determine behavior. Behavior near x-intercepts. And this one's not as critical. And step 6 is graph using above information. Sorry, that's kind of getting right messy there. Above information. Okay, so let's see what this looks like. Okay, here we go. So on this first one, we've got a function. I've got to see the degree on here. So let's go ahead and multiply this out. X minus 3 times x minus 3, that's going to give us x squared minus 6x plus 9. And now we've got to go ahead and multiply the 2x plus 1 times everything in here. So distribute everything here, and we get 2x cubed. And remember, we don't really care about all these middle terms. I care about the first term and the last term. So 1 times 9, plus 9. I'm not worried about all these in-between things. I just want the leading term, which you get by multiplying the 2 largest exponents, and then the 2 smallest values together. Thus, my degree equals 3. That's good. So the number, my coefficient here is 2. 2 is greater than 0. We know it's a positive number. So those two things together, an odd degree and a positive leading term, tell me my end behavior will go down as x gets large, as x gets smaller, y gets smaller, and as x gets bigger, the y value gets bigger. So those are the two ends. Okay, x-intercept. X-intercept, we set y equal to 0. So that means we take each of these factors here and set them equal to 0. So we get 2x plus 1 equals 0, and solve for x, giving us x equals a negative 1/2. And we also have x minus 3, set that equal to 0. And we get x equals 3. So I have two x-intercepts here, at negative 1/2, 0, and at 3, 0. And let's pick this up in the next video.